Okay, am I coming through fine? Great. So, hello everyone. Thank you for coming to my talk, Groovy-powered clean code. My name is Noam Tenne. If you drop into the terminal and just type in who am I, you'll see that I've been coding on the JVM for approximately 13 years professionally. Right now I work at CodeFresh, where we make the best CI server there is for Docker applications and applications oriented at microservices. I tweet at Noam Tenne, and I also blog tenne.org. So let's get down to business. How many of you guys are familiar with this book, Clean Code? That's a nice majority, that's excellent. I'm really happy. Okay, so just a short primer for those of you who haven't read the book or hadn't had the chance to read the book yet, if you will, okay? I strongly advise that you read this book, okay? If you take anything away from this talk, anything at all, if I'm speaking complete gibberish, if maybe you don't agree with me, just read this book. Trust me in that. The reason I think this book is so important, probably the most important technical article there is for anyone who's doing practical development, is that it teaches us to be better developers through sort of principles. It tries to lay out principles. Some of these principles can be applied using static checking, okay? If you're familiar with a really cool tool called CodeNarc, it can enforce some of those guidelines this book tries to pass on. Things like maybe the length of your methods, or maybe the cyclomatic complexity of your for loops, things like that. The problem is that some of the principles in clean code are up to taste, or up to figuring out, okay? Much like art, you can't say that art is good or not, is beautiful or not. It's not really one right answer. And the same thing with code. There are some definite answers of what's good, what's not, but there are things which are in the gray area. And this book tries to guide us through those areas. Now, I think we can mostly agree that software is craftsmanship, and this is why there's such a strong emphasis on taste. It's trying to develop this taste as a developer for cleaner code. So like I said, there's not always one true answer. So if there's many principles to follow, many guidelines, it's sometimes a bit difficult to tell what's right and what's not. But I think a few guidelines can summarize it all up. One is code reviews. So out of the blue, can your colleague read your code? Okay. Maybe after 6 months of not reading your own code, can you read your code? Can you understand what it does? Okay. How hard is it to refactor legacy code? How hard is it to test code? So, just a small show of hands, how many of you regularly do code reviews? Less. But okay. And how many of you, how do your code reviews look like? Are they more what the fucks per minute or less what the fucks per minute? I think it's a bit of a gauge. The more what the fucks, the dirtier the code. Or perhaps when you're refactoring, is this you while refactoring? Sometimes that's me because I right now work on JavaScript. No, actually that's all the time. It can get difficult, especially with Groovy as being with a sort of dynamic nature. So what are some of the principles that clean code tries to teach us? If you already read the book, bear with me. It'll be short. If you haven't, pay attention. First off, our items have to have meaningful names. What's a meaningful name, really? A meaningful name is one which gives away your intention as the developer. Not the what, not the how, but the why. Okay? And your name should also be searchable, so you can later find it in your code base, because your code base is probably large. And it should also be pronounceable. You should be able to discuss your own code. If we look at functions, there are several principles following for functions. Functions should be small as possible. Functions should have only one single responsibility, if you're familiar with the SRP principle. Functions should respect the levels of abstraction in which they exist. So a function which maybe writes an HTML file should probably not be manipulating bytecode. Functions should have as little side effects as possible. which means if you write in the title of the function where it does say operation X, it should not do operations Y and Z as well. And also the number of arguments that a method accepts can also be a nice gauge of whether the clean code, where one argument being the code is probably clean, 3 arguments is maybe a function should be broken up into different functions, or maybe you should use a data structure, those sort of gauges. It also has guidelines about comments. Now, I personally hate comments. The favorite part that I have with comments is deleting comments. So code should be self-documenting as much as possible. I mean, we don't live in utopia. Some code is a bit convoluted, okay? You can't always write the clearest code. But what are good comments? Good comments are ones which maybe reveal a legal intention. Perhaps they're clarifying. Like we said, our code, no matter how much we try, sometimes just can't be clear. It does a too complex operation. So clarifying comments are good. And also Java docs. I mean, we all come from the Java world. I think most of us, Java docs, comments. But what are bad comments? Bad comments are mumbling comments, redundant comments, misleading comments. I'm sure you've all seen this piece of code where it has a comment above it and there's no connection whatsoever between that code and the comment. For sure you've seen that. Maybe journal comments, people who think that they should put in the comments a replacement for Git or Subversion. We all use SCMs. You do not need to keep a journal of your changes and modifications in the file. Scary comments, I'm sure you've all seen a don't touch this without an explanation of why shouldn't I touch this. That's not very good. And like I said, my favorite, commented out code, straight to the trash can. Also some guidelines about objects versus data structures. So we all come from a fairly object-oriented background, and sometimes we get a little too carried away with it. Sometimes we try to force the objects where they shouldn't be. So the text also contains guidelines of how you create a good balance between data structures and objects. In the same section, we also talk about the levels of access. So for example, the law of Demeter, where it says basically you should have only one level of access between functions. Functions and objects should talk to their friends, not talk to strangers. When we look at error handling, we should always prefer exceptions over maybe error codes. We all see error codes here and there. Exceptions are better because if an error happened, it's probably an exceptional case. And we have an infrastructure which is exceptions, so let's use that. Also, the usage between unchecked and checked exceptions, normally you should prefer unchecked. And also the usage of nulls. Now, there are 2 main problems with nulls. First problem being, every null value is a chance for a null pointer exception. Second one being that every null value requires null handling code, which means more boilerplate, which means more dirt in your code base. The book also pushes strong onto tests, mainly test-driven development, really strong. So I think it's a correct guideline because tests, well, they are your safety net. Tests can tell you when you've broken your code. Tests can give you sample use cases. Tests are like your sort of insurance policy, so you can quickly catch any errors you make. Now, I think we are lucky because in the Groovy community we have a really excellent tool named Spock. So if you're not already using Spock, I strongly urge you to use Spock. It's very declarative. The language is very natural for writing tests. If you've ever seen a comparison between JUnit or test and G-tests between Spock, I think it's a world of difference. I think it's the greatest tool there is in the Groovy. Sorry, Andres, even better than, than Griffin. Okay, and also we have humans. Very important part of working with people and working together in a team is the fact that you can work with people who are better than you, people who can mentor you. Not only mentor, but also review your code. Like we said, reviewing is an important part of coding where we can catch each other's errors. So when you work with someone who's better than you, you don't only learn from their experience, but they also can catch you when you fall. So now that we're done with some of the main principles, let's move on to the next section. So, mentoring young developers in the Java world, I've started receiving the questions of, why should I really try to use Groovy? Why is Groovy preferable now that I have Java 8 with the lambdas and the streams and the nicer concurrency and all that? And it's a good question for someone who tries to compare the two different languages. So, allow me to take you on a small improvisational tour, okay? Let's see if there's really any difference between Java and Groovy. I'll just fire up my IDE. So you can see here, I'll put it on the full screen mode. Right. So, as a functioning alcoholic, the moment I arrive to a new city, the first thing I do is look for cheap drinks. Same thing with Madrid. So I wrote a small application, meaning that I can find cheap drinks easily and get a nice ordered report of where I can find cheap drinks. So I wrote a small Java class. Let's take a quick look at this Java class. You can see that it's very standard. It has the main function. I construct the cheap drinks class. It catches some exceptions which might be thrown. So let's see what the doIt method does. First, we construct a URL. This is a URL which takes us to a custom Google search engine, which is pointed to Yelp, to TripAdvisor, those sort of sites which have many reviews. I give it the engine ID. I give it my API key because Google wants to throttle our requests. And I give it the super classy query, cheap drinks in Madrid, because we are all classy people. So once I have the URL, I can open the stream to it. And once I have the stream, I'll have the content. I'll read the content in and collect the JSON result into a string object. So every request to the query engine, which gives me back a huge JSON document with all the results, pagination information. I want to read that in. So I'll create a small engine to read the JSON code and construct a Java object out of it. So every result contains items, and every item contains a title and a link. So I'll collect these items into a more reduced collection with just the relevant information which interests me. And then I'll create a nice, very styled HTML page with a list of items. Just iterate over every item, push the link and the title into the href, and write it to the disk. Are we all clear up until now? Good. So, what would it look like in Groovy? So, I pre-prepared a small class, okay, which does more or less the same thing. You can see it's an ordinary Groovy class with an ordinary main method. I have all the meta information I need, like the URL and the engine. And once again, I construct my URL. So I have my URL, I have my API key, my engine key, and also the query itself. And you can also see I've added some nice meta class, magic, just so I can encode the items in easily, or at least cleaner, because you can see that the items contain some special characters which might trip up the string and the query. I open up the stream once more, and then I just use the JSON slurper to pass the response object. So in this point, I already have an object which is the same thing. A map with items, a collection of items, each one a result. So I take the items, and I open up a new file on the disk, cheapdrinks.html, give it the writer. I use with write and with stream because it's a lot easier than using try and finally. With write and with stream will basically take the stream, or at least the auto-closable object, and close it once the closure is over. And I use marker builder to generate my beautiful HTML. I think a lot nicer than appending strings. And in my body, I iterate over the results. So you'll see just a few strange lines here. Why do I take the delegate of my OL, the ordered list object? And why do I save it and why do I reference it later? Because if I want to iterate over the results within the HTML builder, and if I just write li like this, the method invocation of li would end up calling it on the iteration closure rather than on the HTML builder closure. So I save the delegate while in the OL closure, and then just later on reference it in my iteration so I can still build HTML within a different closure. And then it's all fine. I don't think I have internet here, so I don't think I can, oh, yeah, maybe. Let's see if it runs. That's the Google engine running right now. Great, so I got the response. Let's see what the page looks like. Let's take the page, throw it in. Nice, classy guide. Everything you need to know about Madrid. Come and ask me later. Okay, so we're more or less clear on this. What are your opinions? What do you think after seeing this? Are you convinced that maybe Java 8 has gotten more similar to Groovy? Is it still worth moving? So if you ask me, I think Java 8 is not as clean as Groovy, yet, at least. So let's see why. What makes Groovy clean in the end? Okay, I think in this demo we've seen a few substantial examples. So first thing is the native JSON support, which I think is beautiful. Okay, if you've noticed in my Java example, how did I convert the string JSON into a JSON object? Well, I take the script engine manager and I get a JavaScript engine, and then I run a script which, what is this? I want a JSON, here's an engine, like, wait, what? So this, my friends, is Nason. Quite a while ago, Java was bundled with a JavaScript engine, specifically Mozilla Rhino, and some time ago it was replaced by a new rewritten engine, Nason. It's supposed to be faster. I think it is faster because it can utilize things such as invoke dynamic. And it puts us in a really kind of strange, weird place where we now have JavaScript, which can call Java libraries and pass through to Java objects which are compatible, sort of like a very weird area. And using this built-in engine, I can now, with Java, also call the extensions, which let me handle JSON parsing. So if we look at the code, we see I just take an ordinary string, convert it to a Java object, but using this engine. So how would it look like using Groovy? Well, you saw. It's just a JSON slurper. Not much to it, just JSON slurper parse. And the same thing can also go with the markup builders. If I try to build some markup, whether it's XML or HTML using Java, still using the core functionality, not using any external libraries, I'd probably be appending strings. This is ugly, it's unmaintainable, there's a lot of repetition here. I don't think that's a very good solution. But using Groovy, what I can do is just use the markup builder. Very expressive, very natural. It's exactly stating my intentions. I'm building an HTML document. Same thing goes with ordinary XML. If you've ever written XML in native Java, again, not using libraries, you've seen this horrendous thing. Horrendous because you have to create objects, and you have to create nodes, and you have to build a tree and set 100 different objects if you want to add an attribute, and it's a pain in the ass, really. I experienced that because some time ago, I wrote an engine. If you're familiar with the Red Hat Linux distribution, you know that they have the Yum Package Manager. Yum Package Manager works with indexes. It downloads the index onto your computer, it knows which packages are in this repository, and then it knows what it can install. These indexes are huge XML files, absolutely huge XML files. You look at them and you want to cry. So huge. Now, you want to build these XML documents with Java. My reaction was more or less this. Because it's super bloated code, very slow, unmaintainable. It was just a nightmare to work with. But how would it look like in Groovy? Exactly the same as the markup builder with HTML. Again, stating exactly your intentions. If we look at JSON, same thing. No surprises, no boilerplate, no extra objects, at least not in your code. Probably in the back, yes, there is a lot going on in the back of the engine, and you'll see a lot of objects created. And it's, well, it used to be wasteful, but now it's a lot more efficient. But again, when you write the code, it's a lot more expressive. If we looked at the checked exceptions as well, when you use Java, you have checked exceptions, and every method has to have the same signature, throws IO exception, throws this exception, throws that. Very tiring. But with Groovy, it just disappears, which means you only reduce the amount of boilerplate code. But all of these things are, I don't want to say trivial, because a lot of work has been put into them. But these things are things which can later on be introduced into a language, at least most of them, maybe not the exceptions, but things such as a JSON builder, the markup builder, those are things which you can pretty easily add into a language, or replace them with a library, which isn't always comfortable, but it works. But I come here also to discuss what makes Groovy really clean, as in what's the biggest differences which the current Java language can't replace yet, or at least anymore, because of reasons such as backwards compatibility, making sure people can still run the Java 4 applications in the enterprise, things like that. And I think Groovy in this area, this is where it really shines, giving us the ability to express in a natural language what we want to do. For example, if I want to read an input stream using Java, I have to have these imports, okay? But using Groovy, all I have to do is this. Can anyone tell me why this is all I have to do? Why I don't need those imports anymore? Anyone at all? Yes? That's right. Very good. We have default imports. Groovy, by default, takes some very common packages and just auto-imports them into our classes so that you don't have to, so that you don't have any extra boilerplate code. Excuse me. Let's take a look at something else. We have the SLF4J annotation, and you can see here that I take the log object and I write a log message. How come I can take this log and just write it? There's no logger field, there's no declaration, there's no new instance. Why can I just write this logger? Very good. The AST transformation annotations. So AST is a really cool feature. I don't want to say dangerous, but it is very powerful, but with power comes great responsibility and all of that. AST lets you hook in to the different phases of the compiler and either add new code, modify code, remove existing code, and just manipulate the AST tree. So you can write global AST transformations, okay? These global AST transformations will apply to all classes, whichever, and you can write them at any phase of the AST. And you can also write the local ones, transformations which will apply like the logger only where you annotated certain class. So I've highlighted the fourth item just because the local AST transformations can apply only from this phase and onwards. But still, a lot of power into the transformations. And the log example is one quite trivial. You can do some really powerful things with AST. So here in this example, you can see that I've got a new list object. If I assert it, it's a pure Java list, Java array list. So how come I can just do the plus method when clearly the Java array list has no plus method? Can anyone tell me why I can do this? So Groovy has this excellent thing called the meta methods. So if we look, very simplified structure of Groovy objects, let's call them the POGOs, plain old Groovy objects. Every Groovy object has a meta class, similar to the prototypes in JavaScript if you've ever used them. And every one of those meta classes also has a reference to the meta class registry. This means when you invoke a certain method on whichever Groovy object you invoke it on, it goes through a certain lookup chain, first on the organic object, then on the local meta class, and finally, at some point, it'll also look in a sort of cache that Groovy has for method invocations or supported methods for the same object type. So if we look at the plus, for example, we can see it's, looking into the Groovy code, it's declared by the default Groovy methods class, which holds a plus method. This ends up being registered into the registry, into the cache. So when you invoke the plus, eventually it'll find it there and, well, give you the result, well, at least what you expected to happen. So if we look at another example, for example, paths.get.text. Very elegant, just take the path and read the text out of it. Why can I use that as well? Can anyone tell me how this one works? Sorry? Implicit getter. Well, this specifically implicit getter, yes, but if I change this into get text, how would it work? So Groovy also has a super powerful feature called the extension modules. So the same thing we've seen with the plus, you can do as well. You can add your own custom methods to certain typed classes in Groovy, which also is a lot more powerful because the same thing I did in my demo, in the Groovy demo, when I took the string meta class and I created the new encode method, which doesn't exist organically, but for that case existed. You can do the same thing, but globally, on all the strings. And you can use it using the, sorry, you can achieve that using the extension modules. How do you write an extension module? Well, first you have to create a new class, okay? And that class has to have a static method. Now this method can return, well, I think whatever type you need it to return. But the important part being that the first argument of the extension module method will be the target type. So if my first argument is an integer, this extension module will apply to all integers. So once I have my class in some sort of package, I register it with a descriptor. You can look it up in the Groovy documentation. It's a very simple descriptor, only states the version just for compatibility reasons and to avoid clashing. It states the different classes, such as this one. So you place that in a directory called metainf/services and register that class using the descriptor. Finally, you take the code you've written and you bundle it in a jar file, okay? And then you can use it. Bundle it in a jar file and load it just like any other jar file and class you use on your class path. Hopefully you're doing it with a build tool such as Gradle and not just taking a USB stick and plugging it into the server and copying a jar file into Tomcat and all that stuff, hopefully. But as you can see, very powerful extensions at your hand. If we look, for example, at scripts, how come I can just take a text file and write this? I can just create a string, pass it on to println, no questions asked. If I just take this give it to the Groovy engine. Why does it work? So, you've guessed correctly. It works because eventually scripts are compiled into normal classes. Also, very simplifying the case, disregarding things such as maybe the fields, global variables, and so forth. The script compiler will just generate a new class, okay, extending script, generate a main method, okay, a run method, and place more or less whatever you've written, again, simplifying the case, place whatever you've written in the script into the run method. Now, that's all nice and dandy. How can I still write the print line? Well, the print line is respected because, like I said, we extend the script, okay? And, well, script contains a print line method, just plain old Java. So you've recalled how at the beginning of the talk we said that clean code is up to taste and sometimes opinion. And I think that is true, and I think that, at least in my opinion, Groovy still has the upper hand of clean code because of the example we've just seen. The fact they can write very meaningful, very intentional code in a much more natural language, I think. I hope you agree with me that the language in Groovy is much more natural. Because coding is a difficult task as is. I mean, sometimes it can get pretty intense if you're trying to figure out a difficult problem. Cognitively, it's very heavy. If you use a language which is very verbose, if you use a language which has a lot of ceremony in it, for any sort of reason, it all adds up into that sort of cognitive overload which we experience. So if we have a language which lets us express ourselves at least more naturally, I think it really eases up on the process of development. But not only eases up the process, the fact that you have cleaner and more natural-looking code means it's also code which is easier to maintain, easier sometimes to debug if you don't experience a different, certain Groovy puzzler by any chance. And, and eventually the code is cleaner because, like I said, more testable, more readable, which means both you and your colleagues can come and read that code again with much less effort. And again, I hope you also agree with me. Any questions? Good. That means it was clear. Oh, here, sorry.
How about the performance? I mean, yeah, we can use it, Groovy for doing some things, but it works lower than if we do it in native Java.
Yes. So, well, I don't think a comparison with a language like Ruby is fitting because it's an evaluated language. So it's just passed and executed normally like JavaScript. So those will mostly fail in terms of performance, which is, I think, why Twitter eventually left. I think it was Ruby. Did they leave Ruby? They left Ruby for Java, for the same reasons. Where using an evaluated language, you hit a certain ceiling in performance terms, which then you can also improve much upon if you use a compiled language. Now, Groovy performance started out pretty badly in the early days, but much like the Java on a JVM, the more work the wonderful guys put into it, the more the performance improves. And I think it also improves much because it's getting more and more closer to the static compilation facilities. So you have like the compile static annotation, okay? Obviously that will speed up things in the end in the runtime. And also things like we say, the extension modules as well. And yet it's just compiled code. No performance, I think there's no performance penalty over there as well. I hope I've answered your question. Anyone else? Yes?
How would you say Groovy compares to Java when it comes to concurrency and the new enhancements with Java 8, for example, parallel streams or executor services? Would you say that it can still maintain its advantage in terms of cleanliness?
I think it can, because Java still has a lot of ceremony it has to maintain. So, for example, the fact that you still have to do, so you have certain keywords where you want to open a stream. So you have like the dot streams, you know, or the dot list, for example. This you will always have to put it, where in Groovy, all you have to do is wrap it with a gparse pool, and the method is there. You don't have to have any extra steps, you know, like, please give me this, then please give me that, and only then you can open the stream, and only then with a Lambda. And I think one of the biggest differences in concurrency between the two is that Lambdas are very strict about the side effects. As in, Lambdas should normally not have side effects, but Groovy closures aren't Lambdas, and it lets you act a lot more freely with interacting with the surrounding code. So both in terms of syntax and in terms of facilities, I think you still have, Groovy is still more expressive. Yes, I hope. Yeah. Okay. Looks like that's it. Thank you.